So we're on the last lesson of Unit 1, Lesson 5, and Lesson 5 is about the tangent ratio. Now remember, in the last two lessons we learned about the sine ratio and the cosine ratio, and the tangent ratio is the third and final ratio. And we're going to learn how to, or I should say review, how to label the sides of a right triangle as opposite, adjacent, and hypotenuse. And then we're going to look at how to use the tangent ratio to find the side length of a right triangle and also an angle. Now remember, with sine and cosine, that sine of an angle is opposite over hypotenuse and cosine is adjacent over hypotenuse. And we're using the acronym SOHCAHTOA to help us remember which side lengths go with which ratio. Sine being opposite hypotenuse, so ka is for cosine, uses adjacent and hypotenuse, and toa then is going to be using opposite and adjacent. So once again, looking at this triangle, which side is which? Well, if we're talking about angle A, which is this one right here, this is going to be our opposite side. This is going to be our hypotenuse, because hypotenuse is always the longest, and this one must be adjacent. So tangent of angle A is opposite divided by adjacent. And in our first example, it asks us to find the value of x. So the first thing we need to do is figure out what information are we given about this triangle, and then we can pick which trigonometric ratio to use, sine, cosine, or tangent, and then just use it to find the value of x. So we're given angle A, which is right here, and we're also given this side length right here, and we're asked to find this side length. So we have to consider what is this side and what is this side in reference to this angle. Well, the 5 must be opposite of the 43 degrees. So this is opposite. And the x, then, since this one has to be the hypotenuse, the x must be adjacent. What uses opposite and adjacent? SOHCAHTOA. Tangent uses opposite and adjacent. So we know that the tangent of an angle, tangent of angle A, is equal to opposite over adjacent. Now we can just substitute in our values. Angle A is 43 degrees, so the tangent of 43 degrees is equal to the opposite, in this case opposite is 5, opposite divided by adjacent, and the adjacent side in this case is x. Now we can figure out what is tan of 43 degrees. That's just going to be some decimal number, and that's going to equal 5 divided by x. So let's use our calculator to figure out what is the tangent of 43 degrees. So we'll bring up our calculator, and we can type in 43 degrees and what is tangent. Remember, we've used the sine and cosine buttons. Make sure you pick the right one, tangent. And the tangent of 43 degrees is 0.9325. 0.9325. 0.9325, and that is equal to 5 divided by x. Now since we want the x by itself, we're going to use our algebra rules like before. We're going to multiply each side by x. That way these x's will cancel, and we'll be left with a 5 equals x times 0.9325. Now we can just divide both sides by 0.9325. That way these two numbers will cancel and we'll just be left with our x. X equals 5 divided by 0.9325, and we can figure out what that value actually is. 5 divided by 0.9325, and we get 5.4. So it's 5.36, and the 6 rounds the 3 up to a 4. So 5.4 would be the length of side x. Find the value of x for this triangle. Again, we need to figure out what information we're given and then choose the right trig ratio to solve for this side length. In this case, we're given angle C is 53.1 degrees. This side, which would be the adjacent side, has a length of 12, and we don't know the opposite side, which is labeled as an x. So what uses opposite and adjacent? Tangent does. So we're going to use our tangent ratio. So tangent of our angle, in this case angle C, is equal to opposite over adjacent. Now we can just plug in our values. So tangent of angle C, which is 53.1 degrees, equals opposite, which is x, divided by adjacent, which is 12. Now what is the tangent of 53.1 degrees? Well, we'll just pull out our calculator and figure that out. So 53.1 degrees, press our tangent button, and you can see we get 1.3319. That 8 rounds up to a 9 because there's a 7 directly after it. So 1.3319. And that is equal to x divided by 12. Now in order to get the x by itself, we're going to multiply both sides by 12. That way these 12s will cancel, and we'll just be left with an x. And so 12 times 1.3319. Seeing as that decimal number is still in my calculator, I'm just going to hit times 12. That way I didn't really round it all. And you can see it's a 15.98, which is very, very close to a 16. Therefore, x must be about 16. Okay, so x equals approximately 16. In this next example, we're asked to find the value of angle A. Now, with the tangent ratio, you have to be especially careful that you get your opposite and adjacent sides correct. Okay, so because we're talking about angle A, our opposite side is going to be 18, and our adjacent side is going to be 23. It wouldn't be hard to mix up the 23 and the 18, so you have to be extra careful with the tangent ratio that you don't do that. So, tangent of angle A is equal to opposite over adjacent. So the tangent of angle A is equal to our opposite is 18, our adjacent is 23. So we know that tangent of angle A is equal to whatever 18 divided by 23 is. So I'll have to pull out the calculator again, and 18 divided by 23 is equal to 0.7826. 0.7826. Okay. So we know that if we were to hit tan of some angle, our answer would be this decimal number. So how do we actually figure out what the angle is? Well, we're going to go tan -1 of that number, just like we did with the sine and cosine to figure out an angle. 7.826. And seeing as that number is actually still in the calculator right now, I'm just going to hit tan -1 of this number. And you can see it's 38 degrees. Okay, so angle A is 38 degrees. And we have found the angle in our triangle. In our last example, we have a word problem. A ladder is leaning against a wall, making a 62-degree angle with the ground. It reaches up to the top of a 3-meter window. How far from the base of the wall are the feet of the ladder? Draw and label a diagram. So I'm going to draw a real rough diagram over here. Let's say here's our wall, and here's our window, here's our ground, and we know that the ladder is reaching up to the top of the window. And we also know, so it reaches up to the top of a 3-meter window. So we know that this side length right here is 3 meters. And we know that it makes a 62-degree angle with the ground. So here's our ladder. We know that this angle is 62 degrees. And we're asked, how far from the base of the wall are the feet of the ladder? Well, here's the feet of the ladder. So how far is the distance from here to here? That's what we're wondering. So we can translate this over a little bit neater perhaps into just a triangle. So this triangle we know has a 62-degree angle, and we want to find out this side length, and we know that this side length is 3 meters. Well, according to this angle, we have the opposite side and we want to know the adjacent side. So we're going to use our tangent ratio. So tangent of our angle is equal to opposite, in this case, opposite of the angle is 3, divided by adjacent. And our adjacent is x. I picked an x to label my unknown side. You could pick whatever letter you want. And now we're just going to use our normal algebra rules and solve for x. So tangent of 62 degrees is equal to some decimal number. That's our ratio. So tangent of 62 degrees, we'll type in a 62 and make sure you're on tangent, not tan negative 1. So 62 degrees, tangent of 62 degrees is 1.8807. 1.8807. And that's equal to 3 divided by x. Just like before, we're going to multiply both sides by x. These will cancel each other out, and we'll just be left with a 3 on this side. And we have x times 1.8807 is equal to 3. So we'll divide both sides by 1.8807. And we'll be left with x equals, because these two values cancel each other out, x equals whatever 3 divided by 1.8807 is equal to. So 3 divided by 1.8807, and that's equal to 1.595, etc., etc. Because we're getting a side length or a distance, I'm going to round this to 1.6. 1.6. So x must be approximately 1.6 meters. The distance from the feet of the ladder to the edge of the wall is 1.6 meters. So in summary, for any right-angled triangle, for a given angle, the sides can be labeled as opposite, adjacent, and hypotenuse. Our tangent ratio is equal to the opposite divided by the adjacent. We can use that ratio to either find an angle value or a side length in a right-angled triangle. Remember to set your calculator to degrees, and we use the tan button to find the ratio, that decimal number, and we use the tan negative 1 button to find the angle.